Our planet is extraordinary. It provides everything life needs. Trillions of creatures, plants, and us.
Well, you look down at the Earth from space, and everything that we know of that's life is down there on that planet, that beautiful planet that you now are going around every hour and a half. And that's almost overwhelming, just the beauty of the Earth.
It's unique in our solar system, but is it unique in the universe?
It's important for us to understand the conditions that led to the formation of the Earth, because then we can look for those conditions around other stars, and if we find those conditions there, then that would suggest that other Earths could be forming elsewhere in the universe.
Could there be other planets like ours among the stars? To find out, we must travel back in time and discover how the Earth was made. Rewind the clock 4.5 billion years, and this is what you see. This speck of dust will become the Earth. By combining with countless others. They're all part of a giant cloud called a stellar nursery. The first step of planetary formation is about to start. An event that will transform the cloud into thousands of infant solar systems, including our own. The same process is happening today, 7,000 light years away, in the Eagle Nebula. Our own solar system formed inside clouds of gas and dust like these.
There are these three trunks of gas, and they're nicknamed the pillars of creation. And they're trillions of miles long. These are huge structures.
The clouds look dense, but they're actually very sparse.
These gas clouds are incredibly tenuous. You'd have to compress basically a mountain's volume worth of this stuff, squeeze it down just to make a little tiny rock like this.
To compress the gas and dust into dense stars and planets takes a supremely powerful event. One that can only follow the death of a giant star. In 2007, the Spitzer Space Telescope captured this image. A ball of hot gas behind the Eagle Nebula. Evidence that a huge star has exploded and sent a vast wall of gas racing toward the pillars.
There's a wave of hot material approaching the pillars of creation, and this may be a shock wave from a supernova, a dying star.
Supernovas briefly outshine entire galaxies. Superheated plasma blasts into space at 70 million miles per hour. A mighty shock wave speeds toward the pillars of creation. When it hits, it will demolish them. It will also create new worlds. Supernova shock waves smash into the pillars, compressing the thin gas and dust into dense clumps. Each is a new star, a new solar system.
molecular cloud minding its own business gets blasted by a supernova explosion, crushing the cloud down into stars and planets.
Wind back 4.5 billion years, and our solar system starts the same way. A supernova crushes a massive, dusty cloud into a protoplanetary disk. A thin, nebulous cloud becomes a dense whirlpool of gas and dust. A solar system in the making. One star is destroyed. A new star is born. Our sun and its planets. This is the first link in the long and unlikely chain of events that made our world. For Earth to even be here, we had to beat astronomical odds.
A host of different factors have to line up to get a planet just like the Earth. You have to have the right distance, the right size, the right kind of moon.
On Earth, all the conditions are just right for life.
To get a world like ours, you need a lot of aces. Somehow, our solar system hit the jackpot. But the big question is, did it happen anywhere else?
One of the universe's most violent events triggered the birth of our planet. A sparse cloud crushed into a dense swirl of dust. Some of this dust will become planet Earth. But how do tiny dust grains create entire worlds? A supernova explosion triggers a chain of events that will eventually create the Earth. The formation of our solar system. A hot ball of gas grows in the center. This will become our sun. The dust that swirls around it will form the planets. But first, the grains must stick together.
So we have this interesting conundrum, right? So this disk consists of gas and dust particles. They're about the size of, let's say, particles in smoke, right? Let's say cigarette smoke, right? So these are small things. And somehow we have to get from those little grains to what we see on the Earth.
Gravity is a powerful attractive force. It shapes galaxies and solar systems. But specks of dust are far too small to pull on each other. Somehow, they clump together to form planets. So if gravity doesn't bind them, what does? In Germany, scientists are on the case. They can simulate how dust behaves in space inside a huge tower.
Here we do free fall experiments. So the whole experimental setup, including our dust aggregates, are in perfect free fall. It is simulation of space, but a very good one indeed. I think this is the closest you can get to space on Earth.
Researchers place dust in a container and load it into a launch capsule. At the base of the tower, they lower it into a super powerful catapult. This launches the half-ton capsule from 0 to over 100 miles per hour in a quarter of a second. 400 feet up, the capsule reaches the top of the tower, then plunges back down. A drum of polystyrene balls 30 feet deep breaks its fall. All this gives just 10 seconds of zero gravity, just enough time They hope for the dust to stick.
3, 2, 1, and go.
Moments after the capsule launches, the dust inside becomes weightless. The grains clump together, just like the early solar system. These images reveal how dust particles came together 4.5 billion years ago to form the Earth.
The force that binds the aggregates together is not gravity. They are too small for gravity to be efficient. We think the force that binds the aggregates together is electrostatic force.
It's the same reason that when you pull your clothes out of the dryer, you know how the clothes sometimes stick to you? That's the same effect that allows one dust particle to stick to another.
Dust particles join to form balls of fluff.
The little static charges that they have can make them stick when they hit. And you get something sort of like the dust bunnies that I have a lot of underneath my bed.
These cosmic dust bunnies are planets in the making. They start out smaller than a pinhead, then grow. The dust is now in clumps, but it's still just balls of dust. Turning dust balls into rocks takes a whole new process. A cosmic electric storm. Space clouds build up charge just like clouds here on Earth, generating huge bolts of lightning.
Balls of dust can turn into solid rocks by an energetic event like lightning.
The electric bolts smash through the dust balls and heat them to 3,000 degrees Fahrenheit. In minutes, they cool and fuse into solid rock. Meteorites today still carry these ancient rock balls inside them. These tiny globules were once the building blocks of planets. To form the Earth, these tiny balls must collide, stick, and grow.
Rocks begin to build up by accidental collisions, which can take a long time.
Eventually, the protoplanets, as we call them, the baby planets, get the size of asteroids, kilometers across.
The baby Earth is now the size of a few city blocks, big enough for a new force to take charge: gravity.
At that point, a single asteroid will gravitationally attract a neighboring asteroid. And so those two asteroids that would have passed in the night are gravitationally attracted and they hit each other.
Once gravity starts to rear its head, things really speed up because instead of just randomly plowing through material and getting bigger that way, now it's starting to draw material in.
Gravity pulls rocks together, then holds them there to produce bigger and bigger piles of rubble.
So this formation process, which was taking a long time to get to the size where gravity kicks in, suddenly gets kicked into overdrive, and the planet grows very rapidly.
But planets are more than just overgrown rock piles. These rocks are lumpy and inert. How did the Earth become round and full of life? The early solar system is a construction site for planets. Dust sticks together to form rocks. Rocks join to form asteroids. But most asteroids look nothing like Earth.
And when you look look at a close-up of an asteroid, it looks like some kind of distorted peanut, like a potato that's been sort of bashed. You can see giant craters and oblong shapes.
The young Earth is one of billions of misshapen space boulders. To become a planet, it must first become round. That process only starts when it's several hundred miles across, when its own internal gravity begins to change its shape.
Once you get enough material, enough mass, the gravitational force becomes stronger. Any giant mountain will be crushed down by the force of gravity.
The gravity is so strong that can actually break rocks, and the rocks itself can act like a fluid, making an object round.
Huge outcrops of rock crumble and fall. The immense self-gravity of the early Earth crushes it into the most efficient shape. A vast round ball of rock. A lopsided pile of rubble transformed into a miniature world. The Earth has a new shape, but it's still just a ball of rock. Its structure will also soon change. Cosmic rocks and boulders still rain down from space. Each collision heats the ground.
There's a huge amount of energy stored in an object that's moving rapidly, and when that hits the Earth, all that energy is dumped into the material, and that heats it up and melts it. And the Earth became molten and stayed that way for a long time.
The young planet is no longer solid rock. It's a seething, molten mass. Just like this blast furnace at the Severstall plant in Detroit.
Believe it or not, this process behind me makes life on Earth possible.
They feed in ground up iron ore, a mixture of rock and metal. Just like the early Earth. Put iron ore in a furnace, and the heat melts everything.
This molten iron is at 2,700 degrees Fahrenheit. That's about the temperature of the surface of the Earth 4.5 billion years ago. Imagine an entire planet molten. In the distance, you will see thundering volcanoes spewing out lava. It would be a scene right out of Dante's Inferno.
Iron is heavier than rock. Now molten, they separate.
This is amazing. We're witnessing a process which created the very crust of the Earth billions of years ago, the crust that we walk on every day.
Molten rock rises to the surface and cools to form the crust. Molten iron sinks underneath. Inside the Earth, it sank all the way to the planet's core. The rocky surface is where we live. But without Earth's molten iron core, none of us could survive.
This process separated the iron from the rocky minerals. As the iron descended to the center of the Earth, it eventually created a magnetic field, and that's why we're here today.
The molten iron swirls inside the Earth's core and generates a powerful magnetic field around the planet. A cosmic shield against deadly radiation from space. But the young Earth is still small. far smaller than the moon today. This newly formed world must grow. It must also avoid being blown to pieces. Thousands of protoplanets are hurtling around the solar system, and some are heading straight for Earth. It's 100,000 years since our solar system formed. The young Earth already looks like a planet. It's round. It has an iron core and a rocky surface. Yet our baby planet is just a few hundred miles across. It has a long way to go. It must grow 4,000 times more massive. And it has competition. Thousands of other protoplanets shoot through the solar system, often colliding at over 20,000 miles per hour. You can find proof of this ancient destructive era in modern-day Arizona. Not Meteor Crater itself, that's just 50,000 years old, but the asteroid that gouged it out. That was 4.5 billion years old. Mark Sykes and Marvin Kilgore think the asteroid came from a violent event in the early solar system. The asteroid flew through space for billions of years. Then it hit Earth. They aimed to find a fragment of the asteroid, a remnant from the period of planetary formation.
About 6 miles from here is Meteor Crater, and that was an impact 50,000 years or so ago, and it spewed a bunch of pieces out.
They're convinced the original asteroid was rich in iron, so they've come prepared with some impressive metal detectors.
Does it work?
Oh, yeah.
That's the sound we're listening for.
But even with a quad-drawn metal detector, meteorites are hard to find.
Yeah, are you pretty convinced there's nothing there?
I don't really, not detecting anything.
They find metal, but no meteorites.
My great discovery of the afternoon has been this bolt and this piece of wire.
It takes hours of searching and many false alarms. Then, with the light fading, the detector sounds again.
How about that? Success at last.
This meteorite is over 90% iron and nickel. It could only form right in the core of a protoplanet. The protoplanet it came from must have smashed apart in a brutal collision.
Well, in the early solar system, it was a pretty violent place, and these protoplanetary embryos would smash into each other and they would shatter each other, exposing the interior cores like this. It was a very tumultuous time.
Entire worlds reduced to chunks of rock and metal and scattered into outer space. In the early solar system, these vast collisions are common. The young Earth is in danger. The period's name is the Titanomachian, literally, the War of the Titans. All rocky planets, the Earth included, go through this destructive phase. Sometimes they shatter completely. Sometimes one consumes the other.
All the big guys are sort of competing with one another in a very violent way, actually, to see who comes out on top by eating all their neighbors.
The battle lasts over 30 million years. Finally, thousands of protoplanets have combined into a few full-size planets. Mercury, Venus, Earth, Mars, and a fifth planet, Theia. It's racing toward Earth, our planet's last giant impact. Theia is the size of Mars, big enough to destroy the Earth.
If that thing had hit us straight on, it could have literally blown the Earth to bits, and then we wouldn't even have a planet today.
If this Mars-like object had a direct hit with the Earth, perhaps there would have been another asteroid belt where the Earth is today.
But Earth is in luck. Instead of a head-on crash, Theia strikes a glancing blow. It's the most violent event the Earth has ever known. The impact turns the Earth back to a molten world. A vast magma ocean 600 miles deep. The Earth barely survives. And the encounter changes our world forever. Material blasts out into space. Enough rock to build a mountain as wide as America and 10,000 miles high.
It would have been so much energy, so much catastrophe. Huge amounts of material blasted off and went into orbit around the Earth.
The debris forms a huge ring around the Earth. This gathers together to form two rocky bodies, both orbiting the Earth.
Something the size of Mars hit the Earth about 4 billion years ago. Lots of material would have been thrown off. We now think that it may have formed not only one moon, but two.
For millions of years, two moons dominate the Earth's sky. Eventually, they drift together and collide. Two moons merge into one. The massive moon we see today.
There's no other planet that we know of that has a moon as large as ours in comparison to the size of the planet. We're almost a binary planet, two worlds going around each other.
Without this large moon, we might not even be here.
The moon plays a key role in the survival of life here on the Earth. And the reason is that the moon in its orbit stabilizes the Earth.
The moon keeps the Earth spinning at the same angle. That steadies our climate.
The fact that the Earth's axis stays in the same direction as it goes around the sun produces the seasons, but regular seasons, things that life can depend upon as it evolves.
Earth is neither too hot nor too cold for life, thanks to our distance from the sun and our massive moon. The Earth is not covered in ice or steam, but in liquid water. Yet that water must come from somewhere. The newly formed Earth is dry. To get water, our planet must once again face disaster. It's 500 million years since the sun first ignited. 4 billion years from now, the first humans will set foot on Earth. The moon has just formed, and the Earth is a desert.
One of the more amazing ideas in astronomy is that the Earth started out hot and dry. There was no water here originally.
As the planets formed, the sun's intense radiation vaporized the water in the inner solar system. Farther from the sun, temperatures were cooler. So in the outer solar system, ice and water collected on comets and asteroids. While closer to the sun, the young Earth was dry.
So things changed. What happened? How is it that now we have this wonderful water cycle? Well, the water probably came from somewhere else.
If you want to have a solar system that has a lot of water in it, you have to bring it from the outer parts down into the inner parts. And you can do that through comets and asteroids.
Comets and icy asteroids contain huge reserves of water. But they're hundreds of millions of miles from the young Earth. Then, something changes. An event that tosses the asteroids and comets right across the solar system. Jupiter, Saturn, Neptune, Uranus take a cosmic roller coaster ride.
So this isn't an event that happened when the solar system was young. Think of it as more of its teenage breakout years where they just started to party for a while.
The young planets have not yet settled into stable orbits. As their orbits shift, Jupiter and Saturn fall into an intricate dance. Every time Saturn orbits the Sun once, Jupiter orbits twice. So they always line up at the same spot. Each time, gravity tugs them in the same direction. First, they destabilize each other, and then the entire solar system.
The whole thing just goes kaplooey. The analogy I like to use is when a bowling ball hits pins, it just goes bam all over the place. That's what this would have looked like.
Planetary pandemonium. Neptune and Uranus switch places. Saturn races outwards. The giant planets scatter billions of asteroids and comets onto new paths. Many head for Earth.
These asteroids and comets would have been scattered all over the place, right? Some of them hitting the Earth and Moon.
Cosmic missiles bombard the Earth.
We believe that every square inch of the Earth got hit by a comet or an asteroid during this period. It would not have been a fun time to be here.
The bombardment lasts hundreds of millions of years. Until finally, the gas planets settle into the stable orbits we see today, restoring order. But Earth itself has fundamentally changed. Those comets and asteroids were not just made of rock, but of ice, frozen water.
Comets, we know, are made out of ice. They're dirty snowballs in outer space, and even asteroids can bring water and ice to the Earth.
Our oceans are full, thanks to the cosmic hailstorm.
So, next time you're drinking a glass of water, realize that you're probably drinking comet and asteroid juice.
The arrival of water is the final step to create a habitable planet. A sequence of catastrophes has created a world that's perfect for life. But has it happened elsewhere among the stars? Or are we alone? How did we get here? Planet Earth only exists because of a chain of extraordinary events. A lucky throw of cosmic dice.
5 billion years ago, the odds would have seemed extremely slim that a planet like Earth would form in a rather unremarkable arm in the Milky Way galaxy. It's like trying to throw 2 sixes, but with dice that have thousands of sides.
We know it happened once, else we wouldn't be here. But what are the odds it happened elsewhere? That other planets have life. Life like ours needs a planet with the right temperature and size, a stabilizing moon, a protective magnetic field, and just the right amount of water. The conditions must be perfect. Yet amazingly, there may be countless Earth-like planets out there waiting to be found. Thanks to the sheer scale of the universe. We may find one any day now with the Kepler Space Telescope. Jeff Marcy is mission co-investigator.
It has only one goal, and that's to discover Earth-sized planets around other stars that you see in the night sky.
Earth-sized planets are hard to spot. Before Kepler, astronomers took 20 years to discover around 500 planets. Most were gas giants, hundreds of times bigger than Earth. Since Kepler, that number has exploded.
Kepler has already discovered a couple thousand planet candidates. Many of them are members of multi-planet systems, 2, 3, 4, 5, and even 6 planets, all orbiting the same star. So we're finding an absolute avalanche of planets out there among the stars.
Kepler has found one planet only twice the size of Earth and the right temperature for life. We don't know yet if this planet has other Earth-like attributes, like liquid water. But even if it doesn't, there are many more planets out there. Kepler has found only a tiny fraction of them because it only looks at a small part of the sky.
It's not even looking at the whole sky. It's looking at a very tiny slice of stars in the galaxy. And in fact, if you were to look up, you could cover it with just your thumb.
In the whole of our galaxy, there are 200 billion stars. Many will have planets.
Based on our knowledge from Kepler and other searches, something like half of those stars, perhaps even more, harbor planets.
That means at least 100 billion planets have formed in the Milky Way. Earth-like worlds may be rare, but it seems a safe bet they're out there somewhere.
So the odds of getting an Earth-like planet are extremely small, much smaller than getting a double 6 at craps. But if you have a lot of dice, you're guaranteed to get 6s.
And if you have a lot of planets, you're guaranteed to get Earths. There are so many planets in our galaxy. Even if the chances are 1 in a million, there should be thousands of Earth-like worlds.
Our universe at large has hundreds of billions of galaxies, each of which is more or less like our Milky Way. So the number of planets in our universe is virtually uncountable.
Alien Earths must be everywhere.
Now, we haven't discovered even one of them yet, but statistically speaking, it is a rock-solid certainty. There are millions of billions of planets like the Earth out there.
And with that many Earth-like planets, surely some of them will have intelligent life.
I would bet everything, I would bet my house, that there is another Earth out there somewhere.
There really can be no doubt that elsewhere in our universe, there are other smart critters who are asking themselves, gee, I wonder if there are any other intelligent species out there in the universe.
The story of the birth of our planet reveals that we cannot possibly be alone in the universe. The question is not, are we alone? It's how far away are our neighbors? And when will we meet?